And to everybody that's joining us, we've got Tito joining us today to talk about his company, AirMiners. So Tito is the creator and the CEO of AirMiners. It's the largest community of scientists and entrepreneurs and also engineers who are looking to pull carbon from the atmosphere. And they started this in 2017. He's continued to grow his platform by discussing carbon removal via the AirMiners website, social media, and he even has a TED Talk, which I recently watched, and I recommend searching that as well. So I'm pleased to introduce you, Tito Jankowski. And Tito, what's on your mind? Where do you want to take this today? Where you think about talking about AirMiners in general, or
Nice to see everybody. We've got people streaming in. Yeah, I'd love to give a kind of the case for carbon removal, why carbon removal is needed, how it works, how it's happening, and where there's opportunities for new innovators to come up with new startup ideas and things like that, new solutions. Good. So kicking it off, this is again, I'm Tito from AirMiners. We think really differently. We want to challenge the status quo, and the way that we do that is by supporting risk takers to work on solutions to reverse climate change. Of course, the way that we do that is through a startup accelerator, through a fund, through a community of people that are working to all pull together to remove carbon dioxide from the atmosphere. And our overall goal is to remove 1 billion tons of carbon dioxide from the atmosphere by 2030. And to give you a sense of where we are today, that's roughly 100,000x of the 2022 capacity. So we have a lot of work to do, and would love to get people's help and support and come up with ideas and starting new companies, because it's really there's so much white space in this landscape, as you'll hear about today. So quick overview is, why do we need to remove carbon from the atmosphere? How are we doing it? How's it being stored once you remove it? Then some of the economics, like how are the companies making money doing this, right? Like how do you make money pulling carbon dioxide from the sky? Getting into some of the methods and the pros and cons of each. And again, too, like thinking about energy sources and whether now is a good time to start a company. So why do we need to remove carbon dioxide from the atmosphere? So there's molecules of carbon in the atmosphere. Why do we need to take them out? It's because decarbonization is not enough. Decarbonization means reducing carbon emissions. So reducing carbon emissions is not enough to keep us at a 1.5, 2 degree world in terms of warming. So you can see on this chart, decarbonization, we got to decarbonize 100%. And to get to those 2 degree of warming, 1.5 degree of warming scenarios, we do need to remove carbon from the air. And so that's why decarbonization isn't enough. We also need to actually take molecules of carbon dioxide that are in the air, take those back out. And so you might have also heard of geoengineering in the sense of reflecting sunlight, reducing heating, things like that. I'm a fan, but those things, they buy us time. They don't actually solve the problem. The problem is greenhouse gases in the atmosphere retain heat and cause the planet to warm. So reflecting sunlight, reducing that heating, it slows down the heating of the planet, but it doesn't actually reduce the underlying cause, which is carbon dioxide in the air. So I'm going to show you some pictures of what the difference looks like. The difference between 1.5 degrees and 2 degrees, like you saw on that chart. 2 degrees, we need some carbon removal. 1.5 degrees, we need a lot of carbon removal. And so, that seems like a 0.5. What's the difference? This is the difference between a world at 1.5 degrees and 3 degrees. So you could go from a world that's livable to a world that's underwater. Similarly, a world that's livable in Taiwan to a world that's not. And these are all renderings of kind of potential futures of what the world looks like at 3 degrees warming scenario. So you really, we need to remove carbon dioxide. Decarbonization is not enough, and we have limited time to do it. So let's get to work. Let's figure out how to remove carbon from the air. So that's why we need to remove carbon from the air. Good. So how is CO2 being removed from the atmosphere? How is it being stored? Because that's a common objection, right? It's like, okay, you're grabbing onto carbon, but like, what if you let it go? Like, what? Then it goes back. So you don't want that. You want it to be removed and stored. And then it's like, well, how is this going to make money? Like, what is this something we're just going to do out of the goodness of our hearts? Like, how do we build an economy around this? So let's get to it. So the first question is just a little bit of an overview of what revenue models are for how to pull carbon dioxide from the atmosphere, and then I'll kind of quickly get into how companies are doing it. So carbon credits are a way of accounting for how much carbon that you've removed. You've probably heard of carbon offsets, which is where you get kind of a credit for not emitting, but these are specifically carbon removal credits. So if you're removing carbon, there's a way to account for it, and a way to therefore build an economy around it. The second option is to make products out of carbon dioxide from the air. So you're able to make materials locally by pulling material out of the air, processing it, be able to shortcut supply chains and things like that. And we also see companies that are doing kind of a hybrid of both. They're both removing carbon from the air and then making products with it and getting carbon credits. So let's go through a couple quick examples of how to remove carbon. One is terrestrial carbon removal. Really, that centers on, you're talking about photosynthesis. And again, going back to Matt, your question of does this happen regularly? It does. And so the opportunity here is how do we speed up photosynthesis? So photosynthesis currently it makes things like soil carbon, forestry. We can take biomass and store it more permanently, store the carbon more permanently as biochar or bio-oil. And so terrestrial carbon removal has to do with harnessing that photosynthesis pathway and speeding it up. So soils, forestry, biochar, bio-oil, quick pros and cons there. I won't get too much into details here, but overall, a good pathway. The cons are a lot of it does come back down to your feedstocks. How much biomass can you get without starting to encroach on other things, land use, food supplies, things like that. But it is, and on the pro side, there are terrestrial removal methods that are highly permanent, which is a concern for things on the kind of soil and forestry. And is, a tree captures carbon dioxide, but if that tree rots or burns, the carbon dioxide is then released back out. And so what we call that in carbon removal is kind of low permanence versus something like, taking biomass, making a bio-oil and then injecting it back underground is a more permanent removal of it. It's underground. It's not being returned back to the atmosphere. That's ultimately the problem that we're solving for is carbon dioxide out of the atmosphere and put it somewhere else. So a couple examples, Indigo Ag, they're working on carbon farming, helping farmers pull carbon from the sky and keep it out of the sky. A drone seed, restoring land after wildfires. So instead of the cost of planting a tree, I've heard it's about $1 to plant a tree. They're able to use drones to reduce that cost to, I think, pennies. So you're able to significantly shrink the cost of reforestation. Takachar is a biochar company that I mentioned the topic of biochar. So taking wood waste, agricultural waste, turning into biochar, which is a more permanent material that's made of carbon that can be used as a fertilizer or just simply a way to store carbon. And finally, Charm Industrial. The stuff on the right upper right, that gooey looking stuff is bio oil. That is a more permanent version of you taking biomass and removing it more permanently from the air. So then that's terrestrial. So on the other hand, you've got ocean-based carbon removal. And so here you're in some of these pathways, you're still harnessing photosynthesis. For example, growing a bunch of seaweed and then sinking it to the bottom of the ocean. It has potentially high permanence there if the seaweed never rots or releases its carbon dioxide back out. And then you also have, instead of photosynthesis, you also have a pathway of ocean absorption, which again is currently a place where a lot of our current emissions are in fact being removed naturally by the ocean. So the carbon that we've added in our lifetimes, a lot of that has already been removed by the ocean, but we're adding so much that that's why the carbon rate, the carbon in the air is continuing to climb as the ocean doesn't remove that carbon dioxide fast enough. And so we have some pathways around carbonate formation to accelerate that. So how do we amplify that the ocean's ability to remove carbon? I mentioned seaweed sinking already, ocean alkalinity enhancement, electrochemistry. Again, these are ways to harness the ocean to remove carbon dioxide from the atmosphere. Compared to terrestrial biomass and some of the others, other pathways, the ecology impacts are really, they're unintended, they're unknown, need to be really measured and quantified. Whereas, for example, when you're taking biomass and making a bio oil out of it, you can just track, well, how many, what's the weight of all the trees that we put through our process? What's the weight of all the biomass that went through our process? What's the weight of the bio oil that came out? It's really easy to measure and track that. Whereas with seaweed sinking or alkalinity enhancement, it can be more of a risk around like, well, how do we actually measure this stuff? How do we know it's actually being removed? So for example, here's Running Tide. They're doing seaweed sinking. So they make these biodegradable buoys, it grows kelp, and then the whole thing sinks to the bottom of the ocean. And the thesis is that the seaweed, because it's able to make it to the ocean floor, it'll be stuck there for millennia. So you've got carbon dioxide that was in the air. You use photosynthesis to take it out, and then you're putting it into a place where it doesn't come back out. Here's an example of the more electrochemical process using the ocean and carbonates as a carbon dioxide storage place, and Planetary Technology is doing another method to using mining waste to sequester carbon dioxide in seawater. So again, you're trying to accelerate this reaction that the ocean is again normally doing. You're just trying to make it go faster. So you're adding more material to react to remove carbon dioxide. Next up is direct air capture, and so this is one of the sexier carbon removal topics. Basically, it's a giant vacuum machine that's taking carbon dioxide from the ambient air and storing it and removing it. So it's these big fan systems that are basically sucking in air, pulling out the very small amount of carbon dioxide that's in the air, holding on to it, and storing it. That said, direct air capture itself doesn't actually store the carbon, it captures the carbon. So it's a way to grab onto carbon dioxide, but if you, again, let it back out, it doesn't do anything. So you have to pair this with a storage method. These are extremely energy intensive. I mean, compared to something like growing seaweed in the ocean or using biomass to biochar or bio oil. Direct air capture is energy intensive. It requires most of the devices require like a temperature swing. So you're capturing carbon, you're heating up a sorbent, releasing the carbon dioxide, and kind of running that cycle over and over again. So it's on the higher end for the cost per ton. But you might have seen these. These are been in the New York Times, cover of Wired. Climeworks and Carbon Engineering are two examples, and you can see what these facilities look like, which is basically like a giant vacuum cleaner for the planet. Another company, Noya, is retrofitting cooling towers. They're already moving air around. How can we harness that to pull carbon from the sky? So I mentioned direct air capture is really good at capturing, but it's not a solution for storage. This is where geologic carbon removal comes in as a storage function for carbon dioxide. So you're again using kind of this chemical reaction to create a permanent way that carbon dioxide gets locked up as a mineral, which is locked up for a really long time. Example of this is Carbfix in 4401. Carbfix, for example, partnered with Climeworks. So Climeworks is doing the direct air capture, they're grabbing onto the carbon, and then Carbfix has a facility where they combine the CO2 with water, and then they inject it underground into basalt rock, where it's permanently removed over millennia. So it forms a mineral reaction that isn't naturally being released through degradation or burning, like kind of biomass solutions might run into. Carbon minerals is another example of this, using waste rock to store carbon dioxide. Lastly, I mentioned taking carbon dioxide out of the air and making things with it. So all those previous methods that I mentioned, geological carbon, why would somebody pay to do that? Well, fundamentally, they're paying for the carbon to get removed, and what that looks like is a carbon credit. And then this last category is products. This is actually like, how do we make useful stuff out of carbon dioxide? Because if you can find an economy, if you can find customers who want to buy things made of carbon dioxide, that's great. So there's already things being made out of carbon dioxide that's pulled from the atmosphere. One common value of these products is they're able to shortcut supply chains. So if you have a detergent or a material that's being made on the other side of the planet, and you have your factory on this other side, and you have to ship in these materials, well, you can shortcut that whole process if you're able to make that detergent or that material on site at your facility. So there's a detergent company that is experimenting with this as a way to shortcut their supply chains. But yeah, there's kind of materials you've heard of: diamonds, car parts, concrete, fabrics, plastics. If you want to get a diamond engagement ring that's made with carbon dioxide captured from the air, you can do that. Called ether diamonds. They've been featured in Vogue and other places. So there's cool things that you can do with carbon dioxide. The challenge is the scale that's needed is on the small side. So diamonds are pure carbon dioxide. That means that when you drive, you are emitting the material to make many diamonds. So for example, a gallon of gas is 3 pounds, and when it's burned, it turns into 6 pounds of carbon dioxide. So if you remove those 6 pounds of carbon dioxide, and you get the carbon back, well, then you can make 3 pounds of diamonds. So it's like, it's really impactful from a way to connect to people, from a way to value carbon, but ultimately, like, 3 pounds of diamonds that's a lot of diamonds. So we need kind of make useful products out of carbon dioxide and sell carbon credits to remove significant volumes of carbon dioxide.
What's the concrete portion? Is this like an additive to concrete to enhance its strength? Is it a standalone form of concrete? Like what's the concrete portion of that?
Yeah, this company called Carbon Cure, they are injecting carbon dioxide back into concrete. Carbon Built is doing this as well. The injecting carbon dioxide back into cement has some strength benefit, and it's just a place to put carbon dioxide that is able to help make building materials more carbon neutral. I believe there's some companies that are working on making carbon negative, which are like overall carbon removal. But some of these products, like Carbon Cure, what they're really doing is they're reducing the environmental footprint of cement, but it's not making it totally carbon neutral or carbon negative.
So is it injected as a gas into the concrete as it's
Yep.
as it's mixing, and it's able to absorb that gas as it cures then?
Yes, exactly. It's in the name, Carbon Cure.
Hmm.
12 is another example of they're making all these different consumer products out of carbon from the air. So now I'm going to get into how do companies how much do these carbon credits sell for? So this is your question around Garrett around pricing. So this is what we're seeing in the voluntary market right now, which is purchasing carbon that's being removed, pre-purchasing carbon that's being removed. You see everything from $50 a ton or below in terms of soil carbon, up to at the high end, you're looking at $1,600 for electrochemistry. You're looking at $2,000 per ton for direct air capture, which is the machines that are pulling carbon from the sky. So you have this giant range. I mean, it's more than an order of magnitude of range in terms of price. A lot of this comes down to permanence. So again, the value of what you're selling all comes down to how much carbon you're removing and how long is it removed for, and what are your costs. And so it's a wide range of pricing that we're seeing by the voluntary market. Generally, what we're predicting for 2030, 2040, 2050 is that the equilibrium is around $100 a ton. It's possible that there's some crazy breakthrough that's able to get scale at below $100 a ton, but right now we'll take big scale, $100 a ton. There's going to be plenty of customers to buy carbon from you at that price. Now, if you do the math on that, 1 billion tons per year, that's going back to that IPCC chart. That's what's the gap we need to get to 1.5 degree scenarios. That's 10 billion tons per year starting in 2050. You multiply that by $100 per ton, that's your $1 trillion industry in 2050. So carbon removal will be a top 20 industry in 2050. And this is what it looks like at that scale. So this is just a kind of a grounding back in like, well, what do these prices mean from an industry standpoint, from like where is this going to be? It's going to be big. It's small right now, but it's getting bigger. I mentioned that voluntary market, it's about $1 billion. You might have seen these announcements, or maybe not. The climate world has lots of stuff going on, but at least if you're following the carbon removal world, Stripe announced this initiative called Frontier. They pulled together a bunch of big corporates, including Stripe, Shopify, McKinsey, BCG Consulting. They committed about $1 billion to make purchases to buy carbon from startup companies that take carbon from the air. Separate initiative, Alphabet, Microsoft, and Salesforce committed $500 million. You have this First Movers Coalition, a lot of logo salad there, but a lot of people looking at making commitments to purchase carbon from the sky. Because again, that if you go back to the driving economic force for carbon removal is pulling carbon from the sky. Again, there's some uses for products, some uses for carbon dioxide that's pulled from the sky, but the majority of the market is going to always be carbon removal credits. There's also this existing market for carbon offsets. You might have seen in the news, there was a Guardian article about Vera and kind of this idea that there's a lot of things called carbon offsets, which are about like, paying to get permission to pollute, and you're paying a carbon offset so you can do that. It's a big market. The article in the Guardian about Vera was that it's kind of the market's not delivering on what it's promising, and one of the benefits of carbon removal is you're actually taking molecules of carbon out of the sky fundamentally. So it's less about behavior changes and things like that, and it's literally we're taking molecules out of the sky. For every molecule, we charge you X dollars. EU is coming online with tying the existing offsets market, tying carbon removal into the existing offsets market. So there's all this money that's waiting that could be unlocked for carbon removal. The US has increased its tax incentives. They announced tax incentives a couple of years back, and now they're increasing them. So you can get $50 to $130 per ton for utilization, and $180 for storage and direct air capture. So the new IRA Act has incentives for carbon removal in there too. So yeah, is now the time to start a carbon removal company? I think it definitely is. Great time. And so I'm going to share some of these numbers around kind of venture capital investors lining up to invest into carbon removal. Lower carbon capital, that's Chris Sacca's from Shark Tank. Chris Sacca from what's his other thing? It's not lower carbon. What is it? Lower something. Anyway, so $350 million fund specifically for carbon removal. So Breakthrough, Amazon, they're starting to unlock money to encourage and invest in carbon removal companies. Like I mentioned, it's a lot of white space. I've got a couple ideas here. The white space is massive. There's things that might be painfully obvious to you that nobody's thought of. Lowercase capital, that's it. So lowercase capital now has a specific fund called Lower Carbon Capital. It's $350 million for carbon removal companies. So that's a major accomplishment, and major capital waiting for startup companies that are removing carbon from the air. This is a set of ideas here: genetic engineering crops, measurement, reporting, verification. That's can we actually know that the carbon was removed? Room temperature DAC. To the question around like energy usage of DAC, but what if it was a room temperature process? New energy sources, always up for those, especially for direct air capture systems. And yeah, our goal as AirMiners is to remove the first billion tons by 2030. Again, we believe in changing the status quo. We work with risk takers who are working to reverse carbon from the air. That means that, of course, we have an accelerator program, we have a fund that we're working on, we've got a community of innovators, scientists, entrepreneurs, engineers, who are all coming together to remove carbon dioxide from the atmosphere. Just quick specifics on it: we have an accelerator called Launchpad. If you're starting a company, you should check that out. All this stuff's on the AirMiners website. We partnered with X Prize on it. Several of the teams that went through the accelerator have now won some of the milestone awards from X Prize. It was 3 of the 15 X Prize winners are AirMiners Launchpad graduates, and 10 of the 15 are members of the AirMiners community. So it's the place to be. If you're starting a company, you can come join the accelerator, join the community. We've got Slack, we've got events. Places for people to connect. We've got coming up. Let's see, we've got a how to sell a carbon credit event coming up. That's basically for anybody that's thinking about starting a company in this space. Like, how do you actually sell these? Who do you charge? How much do you charge? What do those deals look like? We're speaking with 2 founders that are graduates from our accelerator, talking with them. They've sold carbon credits. How do they do it? That's coming up on February 1st. We also have an event on insurance coming up because some of these deals and carbon credit sales, the buyers are requiring that you have insurance. Basically, it guarantees them to get the carbon, even if your company fails or whatnot. So that's also interesting for everybody starting a company. And we're also going to be launching an event on how to raise money. So specifically, how to raise your first $500,000 from investors, and again, speaking with 2 founders that have done it. And we also have a boot up course, which is it's basically it's kind of like a book club with a group. So we break you up into groups of 10. It's people that are new to carbon removal. They want to get a sense of it, and you meet twice a week and go through all the different carbon removal topics. These are links. This is kind of my last page, but it's these are links to all those things that I've mentioned. If you want to join the community, you can connect. If you want to start a company, or you are starting a company, you can join the accelerator. If you're new to carbon removal, you can join the boot up. And again, we've had entrepreneurs start at boot up, go into the community, come up with ideas, share sketches, get help. Then they go on to the accelerator, they sell carbon, they get funded. So that's really what we see as our role in getting to this gigaton goal by 2030, is helping create 300 startup companies in the next 3 or 4 years, because we really there really is a gap in terms of how much carbon we can remove. The market delivered 50,000 tons of carbon removal last year. So getting to a billion tons is a 100,000x growth. So we really do need new people with new ideas. Yeah, and welcome you to check out our events channel on YouTube and our website, airminers.org. And that's an overview of why carbon removal and how you can join in. Dennis, questions? Yeah, Dennis has a question.
Yes, I want to thank you very much for the wonderful presentation. It's an awesome presentation. The AirMiners Boot Up course, is it virtual or in person?
All virtual. Carbon dioxide is distributed evenly throughout the Earth's atmosphere, and so is AirMiners. We really believe in helping people, get connected wherever they are. So it's virtual. We have a couple different time zone connections. So it's we have different areas people can form groups. If you just go on the Boot Up website, it'll say how it works. Thanks, Matt.
Tito, thank you for coming.
Really appreciate all you do.
Very fascinating and interesting discussion.